Welcome back once again. We have started a new chapter that is gravitation, and in gravitation, during these classes, we are basically learning the techniques to solve numerical problems. Uh, we have to apply some of the cases when some of the values are given. We will review or revise our topics which we have already discussed and studied during normal classes or lectures. Now, today's problem is find the acceleration due to gravity on the surface of a Mars. The mass of the Mars is this one, kgs, and its radius is this one. So, if you look at this problem, we have already discussed about to calculate the value of g. So, here it is. If you look at the value of acceleration due to gravity and mass is this one, 1.62, and the radius of mass is 14740. So here is the radius of the mass. Moon is this one, and the radius of mass is this one. But you are given the mass of the mass, you are given the radius of the mass, and what you are asked to calculate the value of g. So this was the formula to calculate value of g. So if you look at, here is the value of g, that is gm over r square. So if you look at, this is the value of g, this is minus 11, and if you look at the value of mass, that is 6 point already given, here it is given 6.242 into 10 raised to power minus 11, and then you are given the value of the distance between the two, that is this one. It is basically equal to the radius of the mass, that is 336 into 10 raised to power 4, and you have taken the square of the distance. By taking the square, you, after putting the value, you have calculated basically the value of g at the surface of the mass. How simple is that? This will be the formula. This will be the same if you are calculating at the surface of Earth, and this will be the same formula used to calculate the surface of the mass. And you need to understand what's the radius of the mass. You need to understand what's the mass of the mass, and then you will multiply the two, and you will be able to calculate the value of g of the mass. So this is the formula to calculate. So it is basically the its value is 6.42 into 10 raised to power 23. So this is more visible. If you will put the values, you will be able to calculate. So what you need, you have to understand what's the formula to calculate value of g at different places. So here is another problem. The acceleration due to gravity on the surface of the moon is 1.6. Radius of the moon is 1740. Find the mass of the moon. So you are asked to calculate the mass of the moon. Look, value of g at the moon is given, that is 1.62 meter per second square, and the radius of the moon is also given. It's kilometer. You have to convert it into meter. You are asked to calculate the mass of the moon. This means that these problems, by using these problems, we can also calculate if the value of g at that place is given or the surface is given. We can also calculate the mass of that object, whatsoever the heavier and the lighter mass is. So this is the technique to put the value. Again, you are using the value of g, formula gm m rm square. So you have simplified it. You are calculating mass of the moon, and this one here, it is divided to the other side. It will be multiplied. So that is this one. Here it is multiplied to the other side. You will bring it, and it will be divided. So if you put the all values, so here it is r square. So what was the radius? Radius is this one, 4. So here is the power 4, and you are basically square in taking the square because radius square. So here is the value of g. Again, it is repeated, and its value is minus 11. If you will put the values in this formula, you will be getting the value of mass of the moon. So this is the technique. If you are given uh, acceleration, gravitational acceleration value at the surface of the moon, you are given the radius of the moon, then you can calculate the mass of the moon. It means in any case, uh, if you are given the mass of that planet, you are asked to calculate mass of the planet, you are given the radius of that planet, and you are also given the value of acceleration, gravitational acceleration of that planet, you can calculate the mass of that. This is the most interesting applications of Newton's law of gravitation to calculate. If anyone asks you, how will you calculate the mass of the any planet, Earth, Moon, or any other planet, so it becomes more easier for you to apply by knowing the mass, the value of gravitational acceleration at that surface and the radius of that object, and you can calculate the mass. So here it is another. So if you look at calculate the value of g at a height that is 366 above the Earth's surface of the radius. So if you look at you are asked to calculate above the surface of the Earth. So suppose this is Earth and here it is above the surface. I am making it a little large so that you can understand easily. So suppose object is at 336 00 above the surface. So what will be here? It will be sent from center of the Earth, and basically you have to calculate the distance or the height of the object starting from this one and ending up to this one. So here it is. So this is the height. So what's the calculated value of g at height? So this one is the height above the surface. This one. So above the surface of that, what's the value of g at this? So look at. So this is a body of mass m. You have raised this body up to a certain height above the surface of the earth. It will be the radius of earth and the height above the earth. This will be the total distance between the centers of these two bodies. So here it is. It will be r re radius of earth plus h. So this is the radius of earth plus h. This is the distance between the two bodies. So here it was kilometer, you have converted into meter. Then this is the radius of the earth. This one is from this point to this point. This will be the radius of earth, and the earth force acts from the radius of the earth. Then how much you have raised it? It is equal to 3600 kilometer. And this one is the value of meters. So what will be the total distance between the center to center of these two bodies? If this is body as of mass m, this one is the earth. So this will be the distance between the two center to center of these two objects, and that is r plus h whole square. You have taken it square. All values are given. Radius of earth is given. Height above the surface of the earth is given. You will put the all values. This is the mass of the earth, that is 24 kgs. This one is 24 kgs. 6 multiplied 10 raised to 24 kgs. So this is the this one is the mass of the earth. This one is 24 kgs. So if you put the values here, it is. If you look at 6 multiplied times for 24 kgs, here is the radius of Earth, and this one, sorry, here is the value of g, and this is the total distance, the height of the object from Earth, radius of Earth up to a 3600. So you add these two, and you will be getting this one. So by this way, you can calculate the value of g at a certain height above the Earth's surface. This is the simplest formula. You will calculate the, you will write the value of, if it is only surface, then it will be r, e, radius of earth. If it is at a height h, you will add the distance between the two, and then you will be able to calculate the, between the two. With this, I thank you very much for your patience. I hope you people have understood to solve the problems related to gravitational acceleration and gravity. Thank you very much.